All right, guys, I'm just going to go through a quick example of how to draw a Lewis dot diagram for one single element, for one single atom of that element, so that when we start looking over bonding and we look over how electrons are shared and transferred, we have some sort of way to draw what we're thinking. So the first step to drawing a Lewis dot diagram is actually to determine the number of valence electrons. Now, valence electrons is the same thing as the number of the electrons in the outer shell of the atom. Okay? An outer shell. So, for example, if I was looking at hydrogen, hydrogen only has one proton, and it only has one electron in its shell, so it would have one valence electron. One valence electron, so that would be hydrogen. But if I looked at helium, it still only has one shell. It has two protons and two electrons. So it would have two valence electrons. And it would keep going like that. So if I looked at potassium, for example, which has the symbol K, it has four shells. So it has 19 different protons, and then it has 1, 2, 3, 4 shells. Okay, we only care about the ones on the outer shell, so all the other shells we know are full. On the outside, since it's in that first column, it is only going to have one valence electron. Okay, so that's what I mean. It's the number of electrons in this shell right here, the outer one. Right? How I figured out how many there were is by looking at the periodic table, and there's a really easy way to figure it out. So if I pull up our periodic table, I know that everything in group 1 has one valence electron. Everything in group 2 has two valence electrons. And then if you skip, because we don't think about transition metals in this class, if we skip over to group 13, there are 3 valence electrons. 14 has 4 valence electrons. 15 has 5 valence electrons, and it keeps going until group 18, which has no valence full shells. So if I want to know, say, how many valence electrons germanium has, I would find germanium. I see it's in the 14th group, so I subtract 10. That means I'm going to have 4 valence electrons. Right? Let's use germanium as our example then. We know it has 4 valence electrons. So we know germanium Ge, 4 valence electrons. Great. So my next step is to draw the symbol. So I'm going to draw it again, Ge. And now I'm going to add 1 dot for every valence electron. And there's a very specific way I need to do that. I can't just say, oh, I want 1, 2, 3, 4 valence electrons. That doesn't work. Instead, we need to spread them out as evenly as possible. So the best way to do that is to do 1 dot, 2, 3, 4 in a clockwise pattern. We can have maximum 8 in most of our elements we talk about in this class. So I have 4 spots filled, and here would be the 5th, 6th, 7th, and 8th spot. Right? So we'll just leave germanium as it is, though. Let's look at another one. Let's look at fluorine. So fluorine is in the 17th group, which means it has 7 valence electrons. So I'm going to go back over here. I've got fluorine. I'm going to draw my symbol, F. It's got 7, so I need 7 dots. So I'll go 1, 2, 3, 4, 5, 6, 7. That's as evenly as I can get it. All right? Notice that on each side of, if it was like a square, I only have 2 dots max for each. That's how you need to draw yours too. Okay? So you can't draw yours to look like, oh, I don't know, fluorine, where you have like 1, 2, 3, 4, and then like 5, 6, 7. That's not how it works. We don't want to do that. We want to evenly space them out. This is the best way to do it. We're going to do one more example. Let's do magnesium. Magnesium, element 12, is in the second group. That means that it has 2 valence electrons. So we'll go back over here. Magnesium, I draw my symbol. Different color. Magnesium. And then I do my 2 dots. 1, 2. That's it. I'm done. This is just to kind of guide us and help us along to draw our dot diagrams. We're going to get more complicated with them. We're going to combine elements and stuff like that. But this is just to start us off. So hopefully that was